we're going to do regression now. And we're going to use the same car data that we used for correlation. If I didn't have that up, I might go to the welcome dialog and use sample files and pick car sales. But I'm not going to. Okay. So the next thing we're going to do is, we're going to do a regression. And we're going to see if there's a relationship between, well, let's do length and wheelbase. We found there was a significant correlation between those two last time. Now we can see how much do we expect the wheelbase to change for every unit of length that does. So we'll go up here to the raw data, so we actually have units. And so we'll start with a graph. Set that. We'll do a graph with a linear fit in it. We'll put length here on the x-axis, and we'll put wheelbase here. Presumably, the car maker can influence both of these, but let's say that this one is what they... You know what? Let's reverse. Let's say that they're going for a specific wheelbase. They want the wheels to have a certain spread, and then that influences how long they make the car. We'll pretend that that's the causal direction. Get rid of the title. And we've got a linear fit line, so we are all set. So okay. And there is our chart. It's got a little thing saying what we think how much of the variation is explained by the line. We'll get rid of that. That's extra. The next thing we're going to do is compute the regression. So we go to Analyze, Regression, Linear. We put wheelbase here. We put length up here. For statistics, that's good. Hit OK. Alright, so wheelbase explains 70% of the variation in the length of the car. This is one way of looking at it if you had more than one thing going at the same time. But this is what we're really interested in. So we say the average car with a wheelbase of 0 would have a length of 28. And that for each unit that the wheelbase increases, the length increases by 1.476 units. Let's go back to the picture here. Will those be inches maybe? 110 inches? That seems like it's a little small. Maybe not. I don't know. Sure, let's say it's inches. Cars would be more than 10 feet long. Yeah, sure, that's a 12-foot long car. Sure, we'll say that's inches. So we say for the length of a car with a wheelbase of 0 would be about 28 inches, pretty small, and that for each inch of wheelbase you have to put on a little bit more than almost an inch and a half of length. Cool. That makes sense. So we would say in Word, there was the length of a car significantly increases when you increase the wheelbase of that car. We'd say slope plus standard error equals 1.48 inches per inch. So that'll cancel out. We'll just do that anyway. Plus standard 0.077 per inch. T 154 equals 19.2. P is less than 0.001. And then we take the picture, paste in there, and there are our results. Sweet, right? I'm going to crop this sucker. Where to let me crop it if SPSS wouldn't. Boom. Lovely. Good times. Center. Beautiful. All right.